are inelastic collisions? So inelastic collisions occur when some of the energy is transferred out of a system so that the kinetic energy at the end is less than the initial kinetic energy. So the total energy is conserved, but some of the energy is changed away from kinetic energy. For our lab setup, the overall purpose of this lab is to investigate collisions between two different objects. So in our experiment, the object is a bouncy ball and the floor. And we're going to drop the ball from 4 different heights. Trial 1 is 10 inches. Trial 2 is 18 inches. Trial 3 is 27.5 inches. And trial 4 is 35.5 inches. And we converted these all to meters. And the bouncy ball weighs 30 grams. We're going to use Tracker to analyze it. So the main question is, will altering the heights the bouncy ball is dropped from affect the transfer of momentum in the inelastic collision? So our experimental variables are the height that the ball is dropped from, which is the 4 heights I just mentioned, and then the dependent variable is the momentum transfer, and the control variables are the mass of the ball, the acceleration of gravity, and then just like the constants that the ball on the ground stay the same.
In terms of some important background, momentum is calculated by P equals mv equation, where P is momentum, V is velocity, and m is the mass of the object. In this specific experiment, however, we need to focus on the change in momentum. Therefore, we need to determine both the initial and final momentum values. To find the velocity, we utilize the software Tracker to determine the velocity throughout the duration of the ball being dropped, and to find the mass, which was consistent as a control variable, which was 30 grams or 0.03 kilograms of the bouncy ball. So in terms of our system schema, the 3 items involved are going to be the bouncy ball, the ground/earth, and the hand of the person. The bouncy ball and the hand will have contact between each other. The bouncy ball and the ground will have gravity and contact during the collision. Same goes for the ground and the person who's standing up with contact on the earth.
For each trial, we used P equals mv to determine the initial and final momentum for the change in momentum in each trial. So for trial 1, we dropped the ball from 10 inches. The collision occurred at 0.223 seconds. The velocity decreased, and the change in momentum was negative 0.0464 kilograms meters per second. In trial 2, we dropped the ball from 18 inches. The collision occurred at 0.267 seconds, and we used P equals mv to determine the change in momentum, which was negative 0.056 kilograms meters per second. Trial 3, we dropped the ball from 27.5 inches. The collision occurred at 0.433 seconds. We used P equals mv to determine the change in momentum, which was negative 0.068 kilograms meters per second. In trial 4, we dropped the ball from 35.5 inches. The collision occurred at 0.40 seconds. We used P equals mv to find the change in momentum, which was negative 0.079 kilograms meters per second.
So in terms of interpreting that data, reflected within this data, we can see that when the ball is dropped from a higher height, it's able to reach a larger velocity before the collision, and this occurs because the ball has more time to speed up due to that constant acceleration of gravity being negative 9.8 meters per second squared before it collides with the ground. So knowing this information and knowing that the mass is a constant value, the larger the velocity, the larger the momentum will be. So in utilizing that P equals mv equation, a larger velocity will result in a larger momentum value. Therefore, the trial with the largest height drop, which is being trial 4, will reach the highest velocity before the collision occurs. Thus, by increasing the distance before the collision will have more of an impact and therefore have a larger transfer of momentum to the ground. So in terms of the energy pie charts, when the ball is initially being held by the hand and before it is dropped, all the energy is going to be potential. As the ball falls, the energy is going to be transformed from potential to kinetic. Therefore, right before the collision between the ground and the ball occurs, all the energy is going to be kinetic energy for the ball. The most important thing to note is that though the heights are changing for each trial, the energy pie charts will remain consistent throughout the whole experiment. The only thing that will be changing is the total energy value. So due to the influence of human error, it's pretty difficult to gather perfect data, and it's nearly impossible to form perfect graphs via Tracker. So in order to resolve this issue, we calculated an error value of plus or minus 0.04, and this was derived from utilizing the standard error measurements that we gathered in the Tracker velocity data for each trial. And some of the error that was difficult to avoid would be things like the position or angle of the hand when the ball was dropped, the initial velocity of the ball when dropped, and the location of the ball when it hit the floor. But these are all things that are kind of beyond the scope of this experiment. So in conclusion, some of the energy was lost from the ball to the ground when the collision occurred. Therefore, this experiment was testing an inelastic collision. The greater the distance the ball was dropped from, the greater velocity the ball had. Therefore, this would result in a larger change in momentum as a result of said larger velocity. Therefore, trial 4 had the largest change in momentum with a value of negative 0.079 kilograms per meters per second. And due to some unavoidable errors, there was a value of uncertainty to account for some variance in this velocity data.